In fact, as long as we're talking about it, let's go back to the sample variance again. We said that the least square sample variance is unbiased, but the maximum likelihood sample variance is not unbiased. That means that on average, the average of the S squares that you've got is not equal to sigma squared. And you can see that because S squared is a chi-square distribution. It's asymmetric. It's got a long, thin tail. However, if you do it over and over and over again, as the number of degrees of freedom in that chi-square gets large, both tails get real thin, and that chi-square distribution gets more and more peaked at the truth. Okay, so let's talk about methods of estimation. Methods by which we concoct estimations. As I mentioned before, the three principal methods by which we construct estimators are method of moments, least squares, and maximum likelihood. Alex, you gave me an answer to a question before. Dave, what do we mean when we talk about what's an intuitive explanation of a method of moments estimator? What are the moments? What is a moment? Is that like a moment in time? Yeah. What's the first moment of any random variable? What, to me? What's the second moment? And that's what you center around. Okay, so the central second moment is the variance. And then the third one is the skewness, and the fourth one is kurtosis, and so on. So the moments are ways that we characterize a distribution's shape, its location and its shape. So with the mean, we know where it's located. By the second moment, we can figure out how spread out it is. By the third moment, we can tell which direction it's skewed. And by the fourth moment, we can tell how curved it is, whether it's peaked or like a plateau, and so on. And how many parameters define the normal distribution? Two. They are. But does the normal distribution have only two moments? No, it has them all. It's a very regular, well-behaved density function. So it has all the moments. So one would think, wouldn't one, that the moments which characterize the distribution are constructed out of the population mean and the population variance. But all the higher order moments are functions of the mean and the variance. How many parameters are there for the Poisson distribution? Just one. The rate parameter defines the Poisson distribution. But does the Poisson have all the moments? Yeah, so all those moments must some in one way or another be constructed out of the population parameters. The sample moments should be analogs to the population moments. So that if the population moments are constructed out of the distribution parameters, by analogy, the sample moments could be constructed out of the sample statistics, like the sample mean and sample variance. And then all we need to do is go back and equate the sample moments stated in terms of the sample statistics and the population moments, which have been stated in terms of the population parameters. And then we solve the set of equations for the unknowns, which are the population parameters. Pretty cool, huh? Yeah.
When does the distribution not have a given moment defined?
Yi-Sung, you got an example of Yi-Sung, Nicole. Oh, I'm sorry. Can you think of an example of a density function which doesn't have the first moment? Yeah. Yeah. You ever heard of the mathematician Cauchy? No. Let me ask you another question. What color is your blouse? Red. The Cauchy distribution would be an example of one. Hillary, what does the Cauchy distribution look like? I don't know. Again, that's just a fact question. You know or you know. Who knows what the Cauchy looks like?
I think I know. Can I make a point I lost earlier? I think it kind of looks like the normal, but with fatter tails.
That's the student's G.
Well, I know the student looks like that. Doesn't the Cauchy also look like that? Right.
I'm first.
Yeah, no, it's okay.
So where's the t-shirt from?
There you go.
So anybody know what the Cauchy looks like? You know what the normal looks like? You know what the chi-square and the F look like? Somebody knows the Cauchy?
Could be asymptotic towards infinity and negative infinity.
Yeah, not negative infinity. It sits on top of the real line, right? Okay, so the Cauchy is asymptotic to the vertical axis, but it never crosses the vertical axis. So it's got a hole in the middle of it. So it doesn't have a first moment. And because it doesn't have a first moment, it doesn't have any of the others either. But it's still a legitimate probability. Because it's just, right. But what event can have a Cauchy? It could be characterized by a Cauchy. Anything that could take any number on the real line except 0. So you have a random variable that can take any real number other than 0. That could follow a Cauchy. So you might ask people a question like, you can't have none of it. How many pounds of... Well, it doesn't have to be a negative number. The average number... Excuse me? I'm trying to think of an example where the random variable can't take the value 0. It's kind of a commonplace. Yeah, I can't think of an example offhand. But we got so many other fish to fry. It's not really important. And we're not going to... I guess it's something you could look up an example on Wikipedia, I guess. But let's go on.